Okay. Real quick, someone was asking me how I do some questions about my neck cam. So, and fusion here. So let me go. This is my neck model. Let's get rid of that sketch if I can. Where's that sketch? That sketch. Okay, so that's my basic neck. So this is my headstock joint. I glue on my heel after I I have everything finished basically. So it's a neck without a heel, and let's get down to the cam. I'm not going to do the top because top's pretty basic. What I do, like I can't even remember if I do slot or whatever for the truss rods. This is actually a little different than my current neck, but we don't have to worry about that. All right, so here's the neck. So so I'm doing. Let's see, where are we going here? Oh yeah, neck. We want neck down. Neck down. Open that up. So what to say about this? I started doing. I used to put my Z and my XYZ right here, but I realized that this area is more important to me to get it perfectly accurate. There's always the opportunity for this to wiggle out one way or the other, the way that I secure stuff to the wasteboard. But it wouldn't really matter if this was off a degree or two because it's just the truss rods. It's not going to make a huge difference. But if this area is not lined up perfectly, it's going to make a big difference. So anyway, this is how I position my neck pointing towards me. First thing I do is a 2D contour. That basically makes the other operations a little easier on the machine. So it separates the stock, and now I have the stock blue tape down to the wasteboard. Um, so it separates the remainder of the stock from this. It's probably a little slower process than it needs to be, but yeah, that's what I do. So I do a 2D contour, and that's probably more step downs than I need to do. But I am cutting into fresh stock. So and it says 345, which seems really long. I could probably speed that up a lot. This is going at 100 inches a minute, and I did a step down of probably point 0.1, 0.125. Seems like it should go faster than that, though. I could probably go at like 150 a minute. Anyway, okay, so the first real operation. So I did that 2D contour, and then I'm doing a pocket here. Sorry, a 3D pocket. And this is going to just clear out all the excess material. It's a clearing operation. Um, I could make this go a lot faster if I knew a little bit more about how to eliminate some of the dumb stuff that it wants to do. But this is going at 110 inches a minute, and it is going um, with a maximum roughing step down to 0.12 inches and stock to leave of 0.02 on both the radial and the axial. Linking is going to be minimum retraction, and what that's going to do is going to clear all. Oh yeah, so the ramp type is helix. I'm always tempted to do plunge, and if I did plunge, it would save a lot of time. It would save all these little curlicues here, which are just slow and stupid. They're not even really. You can see they're not. A lot of times they're not even in the stock, so they're kind of pointless. But ramp is somewhat violent. Not ramp. Plunge is a little bit more violent, and I never really sure when I can use plunge and when I should use ramp. So this says 8 minutes and 18 seconds. My machine always takes quite a bit longer than the estimates, so this one's a little slow, and I could probably speed that up. Then I'm going to do a flat, and that is going to um, it's going to make my surface for my heel, and this is my tongue on my adjustable neck joint. So this is going to flatten what the 2D contour, or sorry, 3D contour left, and I still have my 2D contour showing. Let's get rid of that. So this is actually coming in there, and I have that there's no multiple depths. It's just coming in and just going right to it and finishing it off. So that's that. So then we get into, what is this? Oh, 2D contour. And I'm never sure if the flat leaves a nice edge. A lot of times I just run a little pass or something just to make sure it's all set. And this is a 2D contour just on the edge of my neck joint. It looks like I'm just running those passes um, right against this part here. And again, I probably not necessary, but it lists it as 5 seconds. It probably takes 20 seconds on the machine, so it's worth it to me to make sure that this surface is good. Whether I need to do it or not is kind of irrelevant. Okay, so this is the big one here. This is a parallel, and I was saying that I was telling everybody that I ran perpendicular parallels, but it looks like I didn't. I just ran. I said I was running parallels in two directions, but it looks like I didn't. So look at that. Anyway, this is a parallel perpendicular to the neck. Now the pocket has left me like a faceted neck with big step downs, big blocky step overs, and so this is taking all those down. And let's just see what it says 546. And what do we got here? We got 200 inches a minute and a step over of 0.06. So it's like roughly 1/4 of the bit diameter. Um, and that's it. And yeah, so I run it pretty fast, 200, but it's not really doing a whole lot. Partially for two reasons, because I because I already did that 2D contour and I cut the stock off. So on really the, oops, what did I just do? Oh, stop. Oh, come on. Let's get that back. Can I get that back? Oh, come on. No, not that. That. Yeah, so because I already did the 2D contour, I don't really have much left for this to take off. Well, on the 2D contour, there's not much left there. And then the 3D pocket has taken most of it off too. This is my neck joint here. This is the tongue that goes in my neck. I'm always trying to get this to stop the parallel pass without going over the side. I'm wasting time, but it doesn't. I can't figure out how to do it. So that's that. And then the last one is I do a bore um, here into. This is my adjuster hole, so that's just particular to my design. Let me just run a quick simulation here and see what it looks like. And also I model my stock, which I think is, and then you can see that with my method, I don't really need any fixturing. I just have dowel pins on my board here, here, and here. I have a line scribed into the wasteboard here and here, and I have a dowel pin here, so I can do this without any fixturing. Let's do a simulation. All right, so there we got our stock, and we'll not go too. Let's see how fast we want to go. So this is going to be the 2D contour. It's going to go zip out the stock. It's going to take all that extra material off. Okay. So this is the 2D pocket, and it's just kind of shaping the neck roughly, and in probably a way that could be a lot more efficient. But oh, it's funny. It touches the. It's working on. I wonder if I don't have. It's taking the. It's working down the remainder of the stock. So okay, now it's popping out. So you can see that it's leaving this rough shape. That is just not going to leave a whole lot for the parallel to pass. Okay, now we're doing that face operation, and then we're going to do a couple passes. Sorry, flat. And now we're doing the parallel. It's going to take a while. And that's it. So let me know if you have any questions, but that's how I do it. I don't know that it's the best way to do it. It just has worked for me. I'll just quick show you. I guess I could show you my. I'll just do the headstock too while I'm at it. All right, headstock is similar. Well, it's similar. I don't know. Is it similar? What do I do for the first for the headstock? Let's see. I can't remember if I do it upside down or right side up. I don't think it matters. Head plate, fretboard, neck down. It says, okay, here's headstock down first. Okay, headstock down first. So this is the first way we do it. And, okay, so I modeled the stock for that also. And so, I think I actually, open this up a little bit. I guess I do some dowel pins in this one, do I? Yeah. I think I do some dowel pins in here. What do I do that for? I'm honestly not sure. It's been a while since I did this one. All right. Anyway, I'm going to face the stock here, or face basically the back of the headstock. Then, that's what I'm doing. Then I'm going to do a 2D contour for the perimeter. I'm going to do a parallel for the volute basically, and I don't know if I ask it to leave the surface because I don't really want to do this joint. I want as much meat in the joint as I can, and I'll shape that afterwards. Oh, forgot I said anything. No, I do the whole joint. Maybe I leave stock to leave. Can't remember. Doesn't matter. Okay. Actually, I probably do. Yeah, leave stock to leave there. I hope so. And then flip the headstock over. Headstock up second. So, okay. For some reason, I'm facing both sides. That doesn't make any sense. I shouldn't do that. That's dumb. Because it could potentially make my Z too low. So there's no reason to do that. So, I'm going to do a pocket here. And what this does is just cleans out the majority of the wood in this joint. So I don't have to go blow through there with the parallel or waste time with multiple passes on the parallel. Then parallel pass. And I'm doing a lot with avoiding surfaces because I don't want it to gouge into this at all. But has a perpendicular pass, and you can see like do I have machine steep areas here? I don't know if you know machine steep areas, but it's very helpful. I don't have machine steep areas, so if I click this, you can see here. You see that the pass is going this way. When it gets steep because the step over, because it's steep basically, the step over doesn't catch much, and there's like a big area where if this was a single pass, it wouldn't catch it. And if I hit machine steeper areas, it's going to recalculate it, and it should make. It's going to take a second. Oh, come on. It was a fast computer too. Anyway, it should make it a little bit, the pass is closer here, and that's really handy, but why? Oh, maybe you can't do maybe you can't do machine steep areas and perpendicular passes, so I like the perpendicular pass, and it worked well the last time, so I'm gonna dump that, and then, yeah, so it'll go back to normal. And I'm doing just over here a step over 0.04, which is probably just some random number I came up with in my head. But with the perpendicular passes, it comes out pretty good. And for this, I'm going pretty fast, I'm sure. 100 inches per minute. So that's kind of like my standard speed for everything. And then 2D Pocket is going to do the slots in the headstock. All right. I don't know if anybody's actually still watching this, but that is a lot of my neck cam. I do the heel separately. Where's the heel? That's my heel. And this is again individual to my design because it's this adjustable neck thing. So, and the heel is, it's a little tricky because there's not much to hold on to as far as surface under there, but I've gotten a way to do it. One thing that I learned is that I used to try to machine this face here, and it would always come out with a curve this way. And I realized that the blade was either deflecting, or it's very difficult to machine something that is like right, like at a 90-degree angle like that, and have the blade not make it curved. So I stopped doing that, and I just make this my make the front of this my Z, or sorry, my X and Y, and so I don't machine the surface at all. But I'll show you quick the heel if I can find it. It's kind of interesting, I guess, because it. So this is, I modeled the stock so I don't waste too much wood, because this is glued up with 3 layers of wood. So this is the first layer and then the other 2. So I do the same kind of thing, but because I modeled the stock, the pocket also goes faster because it doesn't have to clear out this part because there's no stock there. So this is clearing out the stock, and then I wonder if this is an older version because I shouldn't be doing that. I shouldn't have that operation. That's weird. I wonder why that's there. So that shouldn't be there because I just said I don't do it. And then, so now that I cleared out the stock, I'm running in a parallel, and I'm only running that in one direction. Oh no, am I running it two? I'm running it in 2 directions, yeah. And then I do a 2D contour just to clean up, 2D contour just to clean up this. And I really shouldn't be running it that way, so I don't really know. I thought this is my most recent version, but could be wrong. And that's it. We can just do a quick simulation on that, and then it will definitely stop. Let's do that simulation. 2D, 3D pocket. And I don't want to touch on that face, but it is. It's thinking that the tool is hitting it, which it isn't, but anyway. That's it. Okay.